Hi developers, I'm Hossein Abdellah, Microsoft MVP. In this video, we'll learn how to use dependency injection with Xamarin Forms applications. We have many dependency injection containers like Unity, Automap, and Ninject. And today, we'll use Unity application block with Xamarin Forms. So for the demo, we'll go from the ground and add some code to our application. So for that, we'll start with an application, Xamarin Forms application that doesn't use dependency injection. Then we'll make that application use dependency injection with Unity. So let's get started. So here I'll start by creating Xamarin Forms application by going here, File, New Project. Under Visual C#, I choose cross-platform and choose this blank XAML app template with Visual Studio. Then this will give me this project or this solution that contains a portable project where I will write the shared code for my user interfaces and for the business logic. Then the code or a project for my Android, iOS and Windows platforms where I can put specific code to each platform. So let's create an application that doesn't use dependency injection. So let's create a simple application. For that, I'll go here to my portable project, right-click and add a folder. Let's call this folder interfaces. And let's add a class for this interface. Let's add an interface actually. This interface will be called DataServices or DataServices because interfaces should start with I. Let's make it public, and this interface will have a method that returns a list of names. The names are of type string. Let's call this method getNames, for example. So this will be the interface that will be implemented by our services. For that, I'll go and create a new folder and create a new service inside that folder. Let's call this one services. Inside this application, that you see this application starts to be looking like an VVM application. Let's call this one Data Services. The Data Services class implements the interface a Data Services, and of course it is a public class. And because it implements a data services, it should implement the method getNames. For the getNames, we'll create a list of names equal new list of type string. This list contains names. I'm going to import some names here. Let's put this one, for example. Then this method will return that list of names. This will be our data services. Our application gets this list of names in order to display them inside the user interface. So to respect the MVVM design pattern, we should use the ViewModel, which in its turn will use these data services to get this data and bind it to the user interface. For that, let's add a new folder for our ViewModels. Let's call it ViewModels. And let's add the class for the ViewModel. So it's of type class. Let's call it ViewModel, main ViewModel. Our main ViewModel is a public class that uses the identify property change it interface let's implement that. Here I'm using ReSharper, which help me to write or to generate code really fast. Inside my main view model, I'll go and create a property of type list of strings, so that I can use the data services to retrieve that list of names inside my data services and bind it to this list of names. So let's create names. Let's make it with backing field so that we can go inside this setter and you call the onProperty changed method. This one will be responsible for refreshing the user interface in each time we get a new list of names. Then inside the constructor, we call the data services. We call the data services class. In order for us to be able to get the list of names from the data services. So we call data services.getNames. This way we'll get this list of names inside our data services to give it to our names property here. So we use the names property to be able to bind this property inside our user interface. So let's go to our user interface here, which is the main page, and here I want to put all my user interfaces inside a views folder. For that, I'll go and add a new folder, call it views, and just put my main page inside the views, because here I consider the main page as a view. So let's go to the main page, and here we'll go and bind this content page to my main view model. Actually, I could do that by going to the code behind here and doing binding context equal new main page or equal main view model. But I won't do this. Instead, I'll go and do that same binding in the XAML code. And we'll see why I do that. So doing that in XAML code is by calling content page dot binding context, and here inside that we call the main view model. Here, of course, as I am calling another class, it should add the XML namespace for that class. So here it's adding, here you see the view models, the namespace where my view model, my main view model lives in. Here it's inside the dependency injection.viewModels, because you see here my main view model is inside this namespace, dependency injection.viewModels. We see that same namespace here. After doing that, now we are ready to access all the properties inside the main view model. Particularly, we want to access this names property so that we can read all the names and show them inside our user interface. So let's go and create a user interface inside our page. Let's create a stack layout with orientation equal vertical. And let's give it a padding equal 20, for example. Oops. Inside this stack layout, we'll create a label which have the text dependency injection. I consider this as the title of my page. Then let's change the color of the text. Let's say it should be let's let's say teal for example, and then I want to give a font for this label. Let's choose the bold one, and then give it a font size, let's choose 30 maybe. And here I want my content page to have the background color white. And after this label, we'll add a list view in which I will display all the names coming from my main view model. So let's say that the item source equal binding. Here I'm binding to my names. My names here, it appears because I did the binding inside this XAML code. If I did the binding inside the code behind, this way, inside the constructor of the code behind, then I won't be able to get IntelliSense for my properties, because here the way this IntelliSense appears is by running or analyzing the code of the XAML part of the code. It doesn't analyze the code behind. For that, it only recognizes the binding context inside the XAML code. It doesn't recognize that with C# code. Okay? So this is the advantage of using binding context inside the XAML code. Now we will bind to the names. Let's add has uneven rows equal true. Let's make some data templates for this list view. So let's go list view dot items template. Let's create a data template. That data template should have a view cell, and inside that view cell I make a label that will display the name of coming from the data service. For that I'll use the binding mechanism, and here I'll bind to whatever value comes from the names list. Here I put this dot, but of course it's I can put it or I can not do that. It's you can remove it. Then specify the text color. I like formatting my user interfaces. Oops, actually this one should be the text. Then for the text color, I'll choose the color navy, for example. Then font size equal 24. So now we have our user interface ready for this application. So here we have created the interface, DataService. Then we have created a class that implements that interface. This class will return a list of names. This list of names will be used by the main view model to retrieve that list of names, put it inside the names property. Then we'll show this names property inside the view here after binding to our main view model. So this is an MVVM application that doesn't yet use dependency injection. So let's just run this application to make sure it's working fine. So let's go to F5. So here it is, our application running on Android emulator or an Android device, and I have that same application running on the iOS simulator. So this application doesn't use yet dependency injection. Now let's make it use dependency injection, and as we said, we'll use Unity application block for the dependency injection container. So let's install Unity application block, which is available as a NuGet package. For that, I'll go to my portable project, go to manage NuGet packages, and from here I'll go to browse and look for Unity application blog. So I search for Unity. And here I get this NuGet package, Unity. Let's install the latest stable version. Hit OK. And you see here I'm installing this package only inside my portable project. I don't need to install it for the Android, iOS, and Windows projects. After installing the Unity dependency injection container, now we'll go to apply the dependency injection. For that, I'll go to my project and add another class. This class is conventionally named ViewModel Locator. This class will be responsible for creating the objects and resolving these objects for my view models. Let's make this class public. And inside the constructor of this class, we'll call the Unity container. For that, let's create a Unity container object which is available inside the Unity NuGet package. Make sure here it's installed by going to references, and here you see we have Microsoft Practices Unity and Microsoft Practices Service Locator. So it's installed. Now I can here go and use this container to store or to register my my objects. Let's go Unity container dot, and here you see we have all the methods for resolving and for registering types or instances. Here I'll go and register a type. The type I will be registering here is the data services. Here, if you see, if we take a look at our main view model, the thing that we want to replace here inside our code is this new data services. We want that our main view model doesn't new objects in itself. We want to remove this this ability from the main view model, so that someone else will do that newing for us. So for that, here inside this Unity container object, I'm going to register a type of type iData services. And here, because iData services is an interface, whenever an object needs this a type of this interface, I'll go and give it the implementation which I created here, which is the data services. Of course, here you can have many implementations of the data service, and here you just specify the one you want to use in your application. Here in some scenarios you want to add the real data services object in your real application, but in the unit test projects you might want to create a mock for this object. After registering this type, now each object that will ask for an object of type iData services, it will get the data services. And here the object that will use that one is the main view model. Here the main view model is using the data services. And here I'll go and get rid of this data services, the new wing. And instead of that, I'll go and inject the data services interface from the constructor. And this is called injection using the constructor. We can also use injection using the properties, but here I'll use the injection using the constructor. Here I'll go to the data services and pass that one here. So here you see we no more have viewing happening inside the main view model, but the viewing is happening inside our view model locator. And each time the main view model asks for an object that implements the interface iDataServices, it will get the object iDataService, because here inside my main view model I'm specifying that by this line of code here. That's cool. Now I'm sure that every object asking for iDataServices will get the DataServices implementation. Now let's also register our main view model. So let's call the Unity container again and register the type. And this time it will be the main view model. With the main view model, here I have some options for the register type, and I'll use the option new lifetime container controlled lifetime manager. This option will enable us to get the same instance of the main view model in each time we are asking for one. So if, for example, you are using your main view model inside two user interfaces, both page 1 and page 2 are binding against this main view model, the same view model. Here, by specifying that this new you want to register the type with value new container controlled lifetime manager, you will get the same main view model for your for both your two user interfaces. Then after that, we'll go and specify the Unity service locator. Unity service locator. This object will help us to set the locator provider. Yes, call it Unity service locator equal new Unity service locator, and here we'll pass our Unity container. After that, we'll call the service locator dot set service locator provider, and specifying that here the one we are using is the Unity service locator. By setting this up, now we are telling that the one responsible for resolving the objects, like here resolving this type of object, will be this Unity service locator object. So now we have resolved all our dependencies, but we have one step to go for it, which that step is now creating a reference for our main view model, and I'll go and do that by creating a public property of type main view model, Let's call it main view model, and main view model will return the main view model that was registered here inside my service locator. So I want to get this service view model registered here, and I can do that by calling the Unity container. But because the Unity container is inside this constructor, I'm going to make it a field. So let's do that with help from ReSharper. Create other, create field. Let's make it read only, and let's also make it have underscore. Now we can use that Unity container. Here we use the Unity container to register objects, but of course we can also use it to resolve objects. And that's what the dependency injection is all about. Is a container that contains all our objects so that we can save them inside that container, and also that operation is called register, and we can also get them with the resolve method. So with the resolve, I'm going to specify that I want to resolve the type main view model, and this time it will go inside the Unity container and get and look for any registered type or any registered object of type main view model. Let's return that. So now this is the basic implementation for the ViewModel Locator. Now we'll go and use this property inside our user interfaces. Here, let's go to the app.xaml, and inside the app.xaml, I'm going to create a resource for my ViewModel Locator so that I can use it later to get the main view model. For that, I'll go here and create a resource dictionary. Inside that resource dictionary, I'm going to create main or ViewModel Locator. Let's give it a key so that we can use it later. Let's call it Locator simply. Here, just be aware that here I'm using the dependency injection XML namespace, which was added automatically using ReSharper. Now I'm ready to use this locator inside my main page. And here you see I get a warning for binding to my main view model. This because here whenever I'm binding to my view model, that view model should be parameterless. It should have no parameters inside its constructor. But here I have a parameter which is the data services. For that, here doesn't accept that. Now we no more want to use this binding context. Instead, I'll use the binding context inside the content page here by going to tell that I want to bind to the source, which is considered as a static resource because here it does have a key. That key is the locator. Now let's go and bind to our locator static resource. See it here, locator. And because the locator is the main or is the ViewModel Locator, it contains this main ViewModel public property. So here inside the binding, I'll go and bind to that main ViewModel. So you see here between these two lines of code, it's almost the same, but with this way I'm getting the main view model from the locator. So now the locator is the object responsible for creating and resolving the objects for my application. It's no more creating or newing the object in each time I want them by some other objects. That's cool. Now we should be able to run this application again and make it work for our Xamarin Forms applications. So let's go and hit F5. Now we have this same application using dependency injection with Unity application block. And the same application, of course, works for iOS and Windows platforms. At the end, I hope this was helpful for you. And of course, with the dependency injection, you can use Unity, AutoMap, or AutoPack, and also Ninject, and some other dependency injection container providers. So thank you.